are in an absolutely phenomenal month in terms of its importance. If you have been slipping up a little bit lately and haven't quite been doing as well as you think you should or know you should, then you can more than make up for it now. And if you've been doing really well and then you just take a nosedive right now, you can crush yourself. The material between now and, quite frankly, more or less May 1st-ish is the bulk of the course in terms of what's going to be on the Regents exam, the most points that you can possibly have, and so on and so forth. So stay super focused, and I think you'll find some really, really positive results that'll have a tremendous impact on your grade. Now, if I just take a little bit of a walk over here to where the calendars are, I put up the new one for the month, seeing how today is the 1st. And we did translating functions yesterday, we're doing it today, we're doing it tomorrow. And then we're going to talk about sequences for a couple of days, and then interest in exponential growth for a few days, which is, again, there's some translating functions involved in that. And then on the 17th, we have a test, okay? And then we'll get up and we'll start going into data, and we'll start doing all of this stuff from data, bless you. Then at the end of the month, on April the 1st, we have a test. And then we have a similar sort of thing set up for the month of April. When we're chopped through with all of that material, quadratics would have been covered. Transforming and translating functions would have been covered. Different types of functions would have been covered. And if you remember, the very first year that this course came out, we had no idea what would be on the test. I remember Mr. Sohal, who's my boss in the mathematics department, walking down the hall at me. He had looked at the test. I hadn't looked at the test yet. And I said, "What did you think?" And he said, "If you don't know functions, you're dead. If you're really good at functions, you're in." So we're in the middle of functions right now. Quadratics and functions, quadratics, equations, inequalities. This is the meat of the test, and if we can produce on this, we're in great shape. Now, these are all functions. These are all quadratic functions. How do I know they're quadratic? Oh, this is not good. How do we know, Hunter? Yeah, the x is squared. X squared, and then over here, when I multiply the x by the x, what do I get? X squared. Okay, so let's take a look at this guy. This is your standard vertex form of a parabola. This is very similar to one of the questions on the quiz. What is the vertex of that parabola? Francesca? Negative 5, 7 is correct. Uh-oh. It's copsitude. You know what you got to do in a copsitude? Just treat it like a teenager.
Yeah, smack it.
Smack it. That's exactly right. There we go. Good. See? A little smack always gets to do what it's supposed to. Negative 5, 7. So I'll go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And remember we said the pattern is 1, 3, 5. It's the odd numbers. And that's, of course, only when the coefficient in front of the x squared is 1. If it was 2, then it would be getting twice as big. Instead of 1, 3, 5, it would be 2, 6, 10. Okay? Next one up. And notice how quickly I graphed that. All right? This is, I don't want you using your calculator on this. I want you to be able to see how easy it is to do. This one, the axis of symmetry. X equals negative b over 2a. God bless. So x will equal the negative of 2 over 2 times 1. So x is negative 1. Now I got to go back and get y. Negative 1 squared is 1. Minus 2 times 1 is negative 2. And then this is negative 8. So the vertex is negative 1, negative 9. And unfortunately, I can't fit it here, but I would go to negative 1, I would go down to negative 9, and then I would do 1, 3, 5, and so on. Okay, the next part, x plus 5 times x minus 1. Now, this we're going to use the symmetry property, Mr. Garzone, of a calculator to help us out. What's the root of this on the left?
5.
No, it's not.
Negative.
Negative 5. What's the root on the right? 1. So I go to negative 5, 1, 2, 3, 4, 5, and I go to 1. What's in the middle between negative 5 and 1? -2. So that's my axis of symmetry running right up and down there. Now, if I plug in a -2, I get 3 times -3, which is -9. And again, likewise, I would go to -2, -9, touch down there, and then up 1, up 3, up 3, up 5, up 5. And connect them. Okay, make sense?
Yep.
Okay, so those are very nice questions to illustrate a number of the different things we've been working on with quadratics. Now I'd like to go to number 8. Quick sketch of the graphs of y equals 1/2 the square root of x and y equals 2 x cubed. Sketch being the key word. Sketch means it doesn't have to be exact. Now, the last couple of days, we have shown you certain types of graphs we want you to recognize. What's that type of graph?
Quadratic.
Quadratic. And what kind of function is that? What?
X
Square. Okay, good. What would be that one?
Ooh.
Absolute value. Good. What's this one? All right, this is going to be parabola. This is going to be absolute value. What's this one going to be?
Square root.
No, cube.
Dang it.
That's cube. Remember, for cube, it looks like it's going to be a parabola, but I don't have to go back up positive yet, because when I cube it, it can get negative, so it goes down. Okay, now, the square root graph went like that. The cube root graph went like that. And there is no other absolute graph. Okay? So it asks for the square root of x, which means it's going to look generally like that, but it's 1/2 in front. Now, what does 1/2 do to a graph? Makes it wider or makes it more narrow? It actually makes it wider. So for instance, like, let's say I had the point 2, 4, which would be, 4, 2, which would be on the original graph. Now it becomes 1/2 of 4, 2 is 4, 1. So, there is my square root graph. And then for 2x cubed, it's going to get bigger faster. So there's my sketch of 2x cubed. Again, we're not looking for exact things. If I wanted exact, I would absolutely put it in the calculator and use the table. I'm just looking for a quick sketch of it. And the biggest thing is you being able to recognize things. Okay, again, graphing without a calculator. Okay? So, So I need to draw a line down the middle here. That looks like the middle. And I'll go here. And let's see, the first one is the square root of x. So there's the square root of x. The next one is 10 plus the square root of x. What happens for p of x?
It goes
Yes, what kind of shift do we call that?
vertical.
Vertical shift. I know it's vertical shift, even though I didn't write the 10 at the end, which I could have done. It's the same thing. It's not under the radical. It's not being grouped with the radical. If it's being grouped with the radical, like in Q, what kind of shift is it? Horizontal. So I would basically come up here to 10, wherever 10 is, and draw the graph. And then for x plus 8, remember we reversed it, so I would kind of go over here, wherever 8 is, and draw my graph like that.
Oops.
Okay? Any questions? Sweet. Okay. So, homework covered. Now, on to the sheet. And you know, I talked about this question yesterday, and I said to you the importance of being able to recognize, look for a common factor first. Is there a common factor? No. So what do we go to?
Plan B.
Plan B. So I'm going to multiply by 2, and I get n squared minus 5n minus 24 equals 0. I factor n minus 8 times n plus 3 equals 0. And then I divide back in by that 2, and I get n minus 4 times 2n plus 3 equals 0. I don't even need to write the equals 0 there. Consider that scrap work. Now, my question to you is this. As you look at your paper, how easy was that for you? It should be, perfect word, Emma, it should be easy. Very easy. Okay? You should look at that and say, I can do this all the time. We've been prepped on this. I can't tell you how many times this year. And here's the thing. Now, the numbers might get a little more awkward, but that's the hardest kind of factoring you will do until you hit 11th grade,
That's the
or
hard.
11th grade math. Yeah, so for you 10th graders. That's the hardest factoring you will ever be asked to do. Now, the numbers might be more difficult, like they might give you a number at the end instead of 24, they might give you 224, but then you just put it in the calculator, y equals 224 divided by x, and see what you could come up with. But my point is, if you know the technique, you're ready for everything, girls, until you're sweet 16. You've learned it all, okay? Maybe it's the guy on the left. Maybe it's the guy on the right. Add 4 to both sides, n equals 4, subtract 3, 2n equals negative 3, divide by 2, n equals negative 3 halves. Do I cross the negative 3 halves out? Yes or no? Do I cross the negative 3 halves out?
No,
Why?
because it's not distance and time.
It's not context. And distance and time are the two most common ones, but there are scenarios where they could come up with the fact that you never have a negative answer. They could come up with one where you never have a positive answer. Let's say it was a word problem and it said something like, how far under sea level? Would you give a positive answer to that? No, because it says under sea level, and what does that denote? A negative. Okay, so, again, that question should be, you should look at that question and just start saying, man, I can ace that question. That is an easy question for me. If you cannot do that, you need to be more of a student and less of a baby. And I don't mean that, well, it is a little bit of a shot, and I do mean it as a bit of a shot. Because every person in here is capable of doing it. I could just motivate you very easily. For example, I'm not saying any of these people don't know how to do this, but I just want to show you that, for sake of example, how much you can do this. Emily, if I said to you that I could get you a day's pitching clinic with Jenny Finch, if you were struggling with it, would you suddenly learn how to do it? You bet I would. Maya, who's the world's greatest archer?
My coach.
Your coach? All right, you already got that whole thing set up. What if I could guarantee you a trip to the Olympics when you turn 21? You could learn how to do it. We both know that. Let's see here. Jalice, I could set you up with Tupac, risen from the dead. Would you learn how? Yeah, I think so too. Who would you like to meet to get you to do it?
I would set you up with like endless bottles of whatever you drink.
High five?
Sure. What would you do?
Really tough.
But
Carry on going.
No, I'm not a big Carrie Underwood guy. You know what? If you want to motivate me, listen. If you want to motivate me, all you got to do is this.
What if we could get you a meeting with Shania Twain?
If I was not a married man and I could get a date with Shania Twain, that would very much motivate me. Did I tell you I actually know somebody who knows her?
No.
Yeah, we're going to be getting another puppy in like the somewhere between late August and Christmas next year, and that particular puppy is going to be a type of puppy called a mini Aussie Shepherd, and their breeder, the breeder we're getting her from, her name's Marianne. Marianne's very good friends with my wife Sue, and she's a great dog person. Well, Marianne is friends with a lady named Diana Janes. Diana Janes went to high school with Shania Twain. And we went to a dog show that Diana Janes was at, and at the dog show, her kids were there. And they said, well, what kind of music do you like? I said, well, I like Springsteen, I like country, I like Christian music. So she goes, you like Shania Twain? Or the kids said it. Yeah, I go, wow, check this out. They took out their cell phones and they had selfies with Shania Twain. When she came into the area, she stopped by, ate dinner, had fun at the house, played with the dogs, the whole deal. And I'm like, oh, you gotta tell me the next time. I will walk there. They live in Ontario. I will walk there to say hello. Of course, when my wife wasn't around, I said that.
My dad knows Leonardo DiCaprio.
Does he? Well, I could
Well, not
actually,
like-
is your dad from Patchogue?
Don't do
Now, this is why I say that. There's a kid from Patchogue named Kevin Connolly.
My dad
Right.
is best friends.
Exactly. And Kevin Connolly's best buds with Leonardo DiCaprio. Kevin Connolly used to wrestle for Oregon, and then even when he became famous, because he's on Entourage, he's in a bunch of different movies, he used to do commercials when he was your age. Kevin Connolly would come back to Patchogue High School, and he was at that time even friends with Leonardo DiCaprio. So I think if I remember right, I know he brought friends from Hollywood to watch the Raiders wrestle back in the day, because we were quite the event. We were on TV and so on and so forth. So I think maybe one of those times DiCaprio set foot in the high school gym, for those who care. So,
I wanna be friends with Leonardo.
yeah, I have no interest in being friends with Leonardo DiCaprio. Okay, all right. So the whole point was not celebrity status, okay? The whole point was to say that if you cared enough,
He did just win his Oscar.
you would know how to factor. Can I tell you something? I despise the Oscar
Why?
because it's self-aggrandizement.
What?
That would be like us having an awards for our class.
Don't we do that? Don't we have
We'll
like,
show up in
the
limos.
best
No, we're gonna have the award for
athletic
the Oscar for the best test performance of the year. We could have an award coming out for the best consistency on homework. We could have the award for the best supporting test in the year for the person who helps everybody else out on their test. What a joke. No, I go out, I do well. Their reward is their $1 million paycheck. It'd be more to the point, more like $70 million paycheck. Okay, to think that they make more money in one movie than you will in your entire life is very, very scary. Okay, now, below,
My mom called him Leonardo da Vinci before.
Leonardo the
She said,
idiot. Okay,
Leonardo.
now, number 2. Below is a graph of a piecewise function f, whose domain is from -5 to 3. Now, you remember piecewise functions earlier in the year. Those are like the snow ones that we did, or the tying the flags problems. Except now, we're not just going to do like a line and then a different line and another line. We're going to do a line meets a parabola. Now, there are 2 functions that can be drawn here. One is g of x and one is h of x. G of x is the f of x function plus 3. Now, what is, this is very important because they love to put questions like this on the regions. What is the role of that plus 3? What does it do?
To go.
What kind of shift is it? Talk to me. Vertical. So everything goes up 3. So just take every point and go up 3.
I kinda just winged it. But
And there it is. Okay? So, but literally, the important point here is to look at the idea that I find points, I go up 3. I find points, I go up 3. I find points, oh, that only went up 2. I should have been up another 1. So, anyway, this one, the x being in the parentheses, what kind of shift is this? Horizontal. So I move every point 4 to the right. 1, 2, 3, 4. 1, 2, 3, 4. That's that part. Now I'm going to go 1, 2, 3, 4. There's that part. Okay? So again, it's casual, it's easy, it's an understanding of where you find vertical and horizontal shift, that if it's horizontal, it's reversed, and then you just take key points like the ends of the graph, points where they cross the axis, zeros, and then you just mark them and swing your graph through there. Okay? Any questions? Okay. So, let us go to the next part of today's lesson. Oui, I speak the French. Okay. Get that? That's pretty funny. Oui, I speak the French. Get it?
no
That's like
potty mouth.
in Spanish at the end. Ah, so sad. Ah, so sad. Okay, with your friends sitting around you, there are 4 graphs there. Figure out which one is which equation. Do it.
Okay. Okay.
Talk to each other. You're all by yourself. You can go in here with Sophie and Francesca. These are like, these are the nicest kids in the school. So you should share a seat with them. Work it out. Go talk. I know I don't talk, at least in math. Speak. Speak.
Yeah, in the
Work together, come on, Sandy, work together, let's go. Mojo?
You know,
Right? Well, it's like for a little while they stole Fonts Mojo. The Mojo is back. You're feeling that Mojo back, aren't you? Let's go for tests and quizzes, high 90s, worked it. The Mojo is returning. You're looking to match vertical and horizontal shift with respect to where the vertex is located. Maggie, did anybody ever accuse you of being exceptionally loud? I don't think so. See, well, you know what it is? It's the law of averages. Maggie sits next to you. So it works if you combine them. What did you do? Have a mental spasm on that person? Or do you not want to talk about it? You know what? Can I tell you something? I am convinced that Maya has a blown-up picture of her face over her archery board. And it's just Greg, I am totally, utterly convinced. Her coach comes up to her trying to motivate her, you know, like baseball coaches walking up, hit the ball with your worst enemy, swing as hard as you can, hit him.
I do that all the time.
Yeah, well, I can see going on.
no, you can't.
First, I want his left eye out. Then I want his right eye out. The nose, okay, next, get the hairs that grow off his nose. Go ahead, now.
Only me and Sherry can get that out.
I can't. Oh yeah, we got that.
I'd like to have a little competition where you shoot a bow and she throws a ball.
Are you talking about accuracy?
Yes. You think she won't do well? She's got a good arm.
I don't think so. Yeah, I don't think I'd beat.
I don't know if you beat her too. I didn't say you would beat her. That's a lot to ask. But I would like to see how you do. And it would also depend distance. I would like something in the 50-foot range.
I shoot at 60 feet.
That works.
Oh, you got it too.
That works. A major league pitcher throws from 60 feet, 6 inches away. And those guys can put it in a coffee cup every single time. The distance that you would have to throw the ball.
Why did you say 6 away?
I said, no, a major league pitcher. The mound in baseball is 60 feet, 6 inches from home plate.
Oh, I thought you said 6 inches.
I said cinches? All right. Ready? Here we go. A little difficult here, but let's go backwards. Let's take the graph and match the equation, because if I try to do it the other way, it might not fit in. This f of x graph, which one is this?
E3.
E3?
E3.
E3, you sunk my battleship. Okay, it's definitely the only one that's negative, so E3 it has to be, because it's a frowny one. So I don't even have to look at the coordinates, it has to be. What about g of x?
Obviously it has to be E1.
E1, right? Because there is no horizontal, no vertical shift. There's only horizontal shift 3 units to the right.
Exactly.
So this is E1.
You're supposed to write it on the nice equation line.
Okay, there we go. Okay, next. Over here, what is it?
E4.
E4, because I'm going to go 2 to the right, down 3. So E4, and that leaves the other one to be whatever.
E2.
E2. Are we good? All right. Well, I got to tell you, that's some really important mathematics terminology that you need to understand. So it leaves the other for whatever.
Actually, I don't know.
Okay.
Wait, what? Did not do the description.
I have no idea how to describe it.
No, it's up there.
Oh, it's up there?
Yeah.
Oh, I didn't see it. Oh, well, all right. It's the same parent function, blah, blah, blah. Translated down 3, left 2. You can match those up with that, right? Can't you?
Just do which one is D4.
All right. Oh, which one is D4? The graph of the function has only one x-intercept. Hey, listen, this is a good question. Excuse me. Where do you think you would find the x-intercept? So which is the only one that touches the x-axis once and only once? G of x.
What?
It only touches right there.
Oh, I didn't know that was considered.
That's an x-intercept as opposed to a y-intercept, which intercepts the y-axis. Are there any other problems with the description? Okay. Very quickly, the function here, I'm going to move down 7.5, right 2.5. F of x equals x minus 2.5 squared plus, minus 7.5. And this is going to be negative 610 for my vertex. All right. Folks, we have one more day of translating stuff around. Hasta la vista. Bye. Toodaloo. Ta-ta. Arrivederci. Smile a lot. Ciao.